Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on November 11th, 2025, about 2 days ago. This paper introduces a 4-agent system that turns natural language requests into full hit discovery workflows, reaching about 80% final accuracy on the toughest benchmark, while baselines like ChEMBL manage about 16%. The paper is titled MADD, Multi-Agent Drug Discovery Orchestra. And as we will see, the end-to-end automation and the scale of validation are really promising for practical drug design. Also, the authors shared a GitHub repo. You'll find a full multi-agent codebase for drug discovery with molecule generation, property prediction, and an AutoML pipeline. It includes setup scripts, Docker for generative models, a fast API backend, a GUI launcher, and agents for data gathering and processing, plus runnable examples and benchmark scripts with step-by-step commands. Alright. Figure 1 shows the end-to-end architecture that turns a natural language request into a complete hit discovery workflow by coordinating 4 specialized agents. The top user interface turns a prompt into a structured request and returns results. The middle agent layer decomposes the query, plans actions, and summarizes outcomes, which reduces mistakes because each role stays focused. The bottom tools tier runs data processing, property prediction, and molecule generation with learned models and docking. Alright. Figure 2 shows that the team built a full benchmark connecting natural language queries, generated molecules, and their measured properties. The left panels illustrate diverse queries across 6 diseases, which stress test the agent's planning. The center flow depicts generation and filtering, where docking score means a computed binding strength and more negative is better. The right panels summarize property distributions, including QED for drug likeness and SA for ease of synthesis. So, Figure 2 set up the benchmark and workflows, and Table 1 now compares multi-agent variance on 3 metrics. Tool selection accuracy measures correct tool picks, response summarization accuracy checks, whether answers are consolidated, and final accuracy combines both. The full system leads with final accuracy around 80%. It also tops tool selection at about 84%. Systems without a dedicated summarizer drop sharply. For instance, the single-agent baseline reaches about 30%, and overloading the orchestrator further hurts coherence. So Table 2 compares final accuracy across datasets and methods. The multi-agent system leads on the small set, reaching about 87%. Performance holds on the medium set at roughly 84%, which signals consistent behavior as tasks get harder. Accuracy on the large set stays near 80%, so end-to-end orchestration remains robust. ChEMBL manages about 15%. Standalone language models are effectively 0. So 2 takeaways stand out. A role-specialized agent team can turn plain language into reliable hit discovery workflows, reaching about 80% accuracy where single agents collapse, and the released benchmark with millions of docking scores sets a reference for future evaluation. The broader implication is practical, lab-ready AI-first drug design. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.